TI Learning Channel. My name is Brother Lambert Dosana Batogbe, your automotive trade theory instructor. Our topic is electronic fuel injection system. By the end of this lesson, you'll be able to achieve the following objectives. Objective 1, define the electronic fuel injection system. 2, state the purpose of the electronic fuel injection system. 3, identify and name the type of electronic fuel injection systems used in modern vehicles. 4, name the major components that form the electronic fuel injection system. And finally, identify the type of sensors and actuators used in the electronic fuel injection system. Let me take you briefly to the background why we need electronic fuel injection system. In the development of the automotives, they were using carburetor system. The carburetor have a lot of deficiencies, I would say disadvantages. 1, carburetor systems supply unequal mixture strength to individual cylinders of the engine. Therefore, at certain ranges and speed, the engine is not able to run smoothly. It had a problem of popping back, which we call fire back at the carburetor. Then you also have a problem of hunting. It means some of the cylinders will receive lean mixture. Therefore, the engine will be galloping. It will not run smoothly. And it also have induction robbery, because unequal mixture strength is supplied to the individual cylinders. Then 2, carburetor system have environmental pollution problems, because it's not able to control the carbon emissions. 3, carburetor system have higher fuel consumption, therefore it is less fuel economical. And 4, carburetor system have inefficient power output of all engine speed and loads. Hence, they have now introduced the electronic petrol injection system. And what is this electronic petrol injection system? It is any system in which pressurized fuel is forced out of the injector nozzle at an atomized state to mix with the stream of air that is drawn into the engine. In other words, it is described as a system in which fuel is pumped under an atomized form to mix the air supplied to the engine. Why do we need the electronic petrol injection in our system? It is to ensure that accurate quantity of fuel is supplied to the engine at all engine speed, ranges, and loads. It improves fuel economy, limits environmental pollution, enhances maximum power output and efficiency of the engine. That's the purpose of the electronic fuel injection system. I want to introduce you to the types of the electronic fuel injection system we have in automobiles. The classification is based on the number of injectors and their position or locations. Therefore, we have 2 designs. We have the single point injection system and the multi-point petrol injection system. As the name denotes, the single point injection system only uses one injector nozzle. And this one injector nozzle is used to deliver the pressurized atomized fuel to the various cylinders of the engine. On your screen, you will see a display of a chart, which I will use to explain this particular system of arrangement. On this chart, this shows that this is where the pressurized fuel is coming from the fuel gallery. This is the injector positioned here to get into the injector. Through the sensors and the ECU, it will be communicated how long this injector is supposed to open and spray the fuel that is going into the airstream. The airstream is coming from, the air cleaner is mounted here. So it will supply to all the individual cylinders of the engine. This is a 4-cylinder engine. This represents the cylinders. This is the inlet manifold. So each of this manifold or inlet port will serve each cylinder. So one injector is used to supply all these cylinders. So the problem with this particular arrangement is that cylinders that are far away at the extreme end, assume this number 1, 2, 3, and 4. It means number 1 and 4, they are at the extreme end. They will at a certain point in time receive lean mixture. So that affects the engine efficiency and operation. That makes the single point injection system not very accurate. Therefore, they have introduced the multi-point injection system. In the multi-point fuel injection system, individual injectors are used to supply the pressurized fuel into the cylinders of the engine. The number of injectors corresponds to the number of cylinders of the engine. There are two designs of this particular one. We have the direct injection and the indirect injection. On your screen, I'm going to show you the direct injection type of the multi-point injection system. This is the multi-point injection system. Over here, the air cleaner is mounted here. This is the inlet manifold. This is the fuel rail, where fuel is normally kept under pressure. These are the individual injectors, 1, 2, 3, and 4, serving each of the cylinders. The fuel under pressure will be delivered to the particular injector that is ready with a signal received from the ECU. Then it will spray the fuel into the combustion chamber. This is the multi-point injection system. The problem of the single point injection system is therefore eliminated because each individual injector will be spraying according to the engine firing order. I've already introduced to you the problems with the single point injection system. So the multi-point injection system is therefore used to overcome the problem of the single point injection system. The advantages of the multi-point injection system are these. 1, fuel is evenly distributed to each cylinder. Engine has a smoother running operation. There is always lower fuel consumption with the multi-point injection system. There is higher power output. When one injector spoils or is defective, the other cylinders can still work instead of the engine completely running off in the case of the single cylinder. That makes the multiple cylinder injection point very effective and efficient for modern engines. Let me also briefly tell you about the disadvantages for the multi-point injection system. We are now comparing the two, single point and multi-point. The single point is very simple in arrangement, less expensive, but you have a disadvantage of supplying lean mixture to certain cylinders. At the same time, it's unable to distribute the mixture strength equally. The multi-point injection system has overcome those difficulties. Meanwhile, it also has some deficiencies, or I'll term that as disadvantages, because there are a number of components that have to be manufactured. Injectors have to be corresponding to the number of cylinders. So you have many injectors. So during servicing, it requires a lot of time. It's expensive for service. Another disadvantage is that you need a qualified technician who is able to use OBD, onboard diagnostics machine, when it comes to fault diagnosis and repairs of such a system. It is much, much complicated. These are the disadvantages of the multi-point. Meanwhile, comparing the advantages is better than the single point injection system. Now let me take you through some of the components of the electronic petrol injection system. We have the ECU. The ECU simply means electronic control unit, which in some case they call it electronic control module. It's a miniature computer that is in the system. It uses microchips, and it is programmed that it receives signals from the input sensors and therefore translate that signals into electrical information and therefore introduce the injectors to the amount of fuel that is needed according to the information that it has received. That is the ECU. we have the injector nozzles. Their duty is to spray the pressurized atomized fuel into the individual cylinders as required. There is an ignition coil. The ignition coil acts like a transformer. It increases the battery voltage from 12 volts up to 24 volts, so that stronger spark will jump the sparking plug gaps to be able to ignite the highly compressed mixture in the combustion chamber. We have cooling temperature sensor. It determines the engine running condition, the ambient condition of the engine, and communicate that to the ECU. So the ECU will supply information to the injectors according to the engine temperature, the amount of mixture that is needed. We have the electronic fuel pump. The electronic fuel pump is designed and it works in this form. It's the one that circulates and drives the fuel that is needed to the various components in the system. The fuel tank acts as a reservoir to store the required quantity of fuel needed for the vehicle operation. There are filters. The filters make sure that clean fuel is supplied to the system. Otherwise, some valves may be blocked and render your system inoperative. There is an accumulator. The accumulator has a spring-loaded diaphragm in it. So it holds the fuel in an equilibrium and makes sure that the pump pulsations are limited. So point of noise, the pump noise will virtually be limited. There's a metering and distribution valve. This valve distributes the fuel according to the throttle position. So it calibrates and therefore delivers to each injector nozzle the amount of fuel is supposed to deliver into the combustion chamber. There is a throttle position sensor. This sensor is like a switch. It senses where the throttle position is, whether it's partially opened or fully opened. That will determine the amount of fuel the engine needs at that particular point in time. There is mass airflow sensor. Usually they will call it MAP sensor. Other people will call it MAP meter. What does it do? It measures the volume and the quantity of mixture or the mass of air that is running into the engine. There is also the oxygen sensor. This oxygen sensor is located in the exhaust stream. It can be located in the exhaust silencer. What does it do? It senses the oxygen content of the exhaust gas and therefore indicate to the ECU, the electronic control unit, the amount of oxygen that is in the system. If it is less or more, it will indicate in a signal form. Therefore, the mixture supplied will match so that you don't have too much fuel coming into the system to cause environmental pollution. So the exhaust sensor is very important component in the system. These are some of the components that are in the system, which I want you to briefly take note of. How does the electronic fuel injection system work? I want to briefly just talk about the operation of it. The first one to be developed was the K-JETRONIC, developed by the Bosch company. The system is using the principle of continuous flow system, whereby there's an airflow sensor to be able to measure the amount of fuel going into the engine. In this arrangement, there is a permanent magnetic electronic motor which drives the roller type of fuel pump. And this pump pressurizes the fuel sufficiently enough to give the required quantity of fuel supply to the engine according to the speed and the load demands. The maximum pressure of the system is regulated by the pressure regulator. It is set to a standard of 4.7 bar. If there's excess fuel in the system, that is, if the pump delivers more than what is needed, the excess fuel is redirected into the fuel tank. That's why they call the system continuous flow. On your screen is the diagram of this system, which I would like to take you through. This is a multi-point injection system. This is a fuel tank. This is a fuel pump. And this is a filter. The fuel is drawn from the tank by the electric pump. This fuel is therefore filtered to make sure that clean fuel gets into your engine Then the fuel comes into the fuel rail, which is pressurized and stay in there and wait till the time that each of the injectors will be signaled to supply fuel into the system. This is the pressure regulator. So the system continues in this form. Excess fuel is sent back into the tank. Then maintaining standard pressure in the system. Anytime the ECU, electronic control unit, will receive information from any of these sensors, and these sensors are called input sensors. They sense the vehicle condition and therefore inform the ECU in an electrical manner to receive that information with electrical signals. Then it will convert that signal into an input for the injector. The injector will open according to the ECU information it is received. It is calibrated and calculated. It will use that data to inform the injectors to supply the fuel accordingly. I did mention that there are various sensors in the system. Here in this particular system, some small acronyms you need to know. TPS simply means throttle position sensor. It will determine the throttle position of your engine. Then the CTS indicates coolant temperature sensor. The OTS is the oil temperature sensor in the system. OS is the oxygen sensor. And then the ATS is the intake air temperature sensor. All these sensors are called input sensors because they communicate with the ECU. And the ECU will get that information, program it through its data information, and supply the injectors according to the needs of the engine at that particular point in time. So in summary, these are the advantages for the multi-point injection system. At the multi-point injection system, supplies accurate fuel at all speed ranges and load of the engine. The mixture strength is equal. It's able to distribute it evenly. It improves fuel economy. It avoids environmental pollution because the oxygen sensor will determine what amount of fuel is supposed to be supplied. It improves engine efficiency. Maximum power is always derived from this particular system. That is why most modern vehicles will now go in for the multi-point injection system. I would like to show you some physical components of this arrangement. This is the layout of the multi-point injection system. This is a simulator that will show you how some of the components are arranged. In this particular system, you see the computer unit, which is the electronic control unit, or electronic control module, ECU. Normally, they call it the brain box of the system. It is connected to the various components so that I can communicate with them. Over here is the ignition coil. The ignition coil is used, as I indicated, to step up the battery voltage to a higher voltage and supply it to the plugs so that they can ignite the highly compressed mixture in the combustion chamber. And that's the spark plug fixed there. This is the inlet manifold. On this inlet manifold, there are a number of sensors in it. The airflow sensor is here. It's called air cleaner is going to come in this direction so that it will measure the amount of air going into the system. The manifold absolute pressure will be measured so that you know the absolute pressure going through the inlet manifold. We have over here the fuel rail. These are the injectors that will serve each injector, each cylinder. So in this particular case, there is a pressure regulator here. It is giving us the amount of fuel pressure in the system. If the fuel pressure is more than what is needed, you can see that there's a valve here. It will redirect the excess to go back into the tank. The tank is fixed at the back over there. So over here, we have the fuel pump, because it will draw the fuel from the tank, which is behind, and pull it through the system. It will come through the fuel filter to make sure that clean fuel is supplied to your system. So basically, this is the layout of the multi-point fuel injection system used in modern engines. To run up, I did inform you that during the beginning that you are going to define what the electronic fuel injection system is. You're able to define the purpose of it. It's to ensure that the accurate quantity of fuel needed at every speed and load of the engine is supplied. It is also to ensure that the correct mixture strength is delivered so that exhaust pollution, because of the oxygen sensor, you'll be able to measure the amount of fuel needed so that you limit environmental pollution. The next point is that we said all this, we want to improve fuel economy. We want to enhance engine performance. So the output of the engine will be very sufficient enough at all speed and ranges. So the electronic fuel injection system is what is needed in our modern technology. For your references to enhance your readings and proper knowledge of this system, I refer you to the following books. Fundamentals of Motor Vehicle Technology, 4th edition, written by Helia. You'll find this information on page 83, and you continue reading from page 112 to 125. Also get hold of M.G. Nuni, Light and Heavy Vehicle Technology, 2nd edition. You can also read that from page 157 to 159. I wish you all the best. Continue reading so that when we meet again, we continue to know more about the electronic fuel injection system, why we need it in the motor vehicle these days. Thank you very much.